everyone, and thank you for coming. My name is Mary Power. I'm actually with the Center for Teaching Excellence. I'm currently the science liaison, but I'm moving to the blended learning, the senior instructional blended learning, senior instructional developer of blended learning when Jane Holbrook retires on Monday. So I'm really excited to hear Maude's talk, because I mean, flipped classrooms are really a form of blended learning. So it's really exciting to see what she's done and really getting the students engaged in the classroom. It's going to be exciting. I'd like to also introduce to you guys who don't know, Thule Algindagay, who's Tamar's replacement. So she is the new liaison for engineering for this year, while Tamar is away on leave. So for those of you who haven't met her, Thule asked me to do this little introduction. So I'm sure you all know Maude Gorbet, and I'm really excited to hear her talk. And I'll just, without any further ado, I'll just let her go ahead and let her tell us about what she's done in her classroom. I'm sure there'll be time for questions.
Yeah. So, well, thank you so much for taking your lunch hour to come listen to me. I'm quite excited to be sharing my experience about flipped classroom. It was a definitely wonderful experience, and I'm going to do it again. It was a lot of work, so just so that you know, you'll see some of the up and downs. And I put some slides together. It's kind of hard to. There was many ways I could have presented this, but I also wanted to make it not too long so that there's lots of questions, because everybody might have a different question in relation to how you organize this for your course and so on. So I don't want to spend a lot of time on how I did it, but I just want to be able to answer some of your questions based on the experience that I've had. So just to give you a little bit of a course context for this course, it's Side 285, and it's a materials chemistry course, a little bit of a material science into it. And way back when I started in 2007, it was a chemistry course, and it wasn't really fitting well with a system student. So we decided about 2 years into it to kind of move it more toward the material science course, do some chemistry, but really apply it to material science. And so I started to do that in 2011, and by 2 years after that, the course was working really well, and the students were enjoying it, and I kind of had fun teaching it. And every time I was teaching it, I would add a little thing to it to make it more interactive. So we tried Top Hat Monocall, we tried some case study. I had speakers to come that were working here on material science, and they would come to the student and talk to them about what they were doing to get a little bit more real world application. We did some mini labs, Idea Clinic when that started. And also I tried to kind of look up in the newspaper or a scientific journal every week to potentially pick up something that was interesting and relevant. So I kind of tried to have a few exciting stuff within the course itself, apart from the lecture component. And really, the student feedback was actually very positive. That's my favorite course. I really like it. But it'd be nice to have more labs. It would be nice to have more real-world example, more applied problem. The course should have labs. Really, we should have hands-on experience. And I was like, yeah, I totally agree. How do I do this? And I went on sabbatical, and I came back, and I taught the course again. And the course was working well. I had all my slides. Everything was going well. And I found myself being bored. I was bored I was giving my lecture, and it was exciting. I was talking to them about things, but I was bored by my slides. And I said, if I'm bored, like somebody at the back is most likely falling asleep, and I can't even get him excited about this news story I'm telling him. So I thought, I need to think about this a little bit more. And also what I was finding, one of the things is that and I discovered more of the concept with one of the workshop with Gord, is that threshold concept. One of the threshold concept for my student was that I wanted them to understand that with material property, one of the key components was really the microstructure. Like it went back all the way to what kind of bondings, those materials that directed the material properties. And I could see in the exam, and I could see in the tutorial session that they were not getting it. And I said, if I want them to take away anything, that's this. And so I was like, how do I go about this? Like, I need them to be able to think about it more. And in tutorial, we have 1 hour, and I don't have the time. It's looking to the formula and doing small exercise, and all those little things I was adding on. weren't working. So I thought, I've got this. I've got all those concepts that I want them to understand. I have all this knowledge that I want to pass to them. How am I going to actually make it more integral to them so that they can actually remember really the key component being my trash concept about understanding like the microstructure of our material, and also learn something in an environment that stimulates them. So the only way I could see was to actually flip my classroom, turn everything upside down. Decide that, I've got all those slide material that's been constructed over the year, and say, I'm going to use that so that they can read it at home, because they can all read. And we're going to start looking at making real use of the time that I have in the classroom to work on problems. Because I always found all those great problems, and we never really had time to do any of them because we were rushed in the tutorial session, or I didn't have time to actually go in and discuss with them some recent applications. So that's really where it all started. And really one of the key things for me that helped me go through that was actually going to the Teaching Excellence Academy workshop and starting working on it and looking at my course objective and thinking, how am I going to do that, flip things upside down with the way I've been teaching? Although I always did a little bit, it was never 100%. So I was safe, I knew how to lecture, and the student knew what they were going into, and suddenly it was going to be this big thing, the road ahead, I have no clue, it's going to be steep. I don't really know, it's pretty dark, I don't know what's going to happen. And then often people see the flipped classroom as this big explosion. It's going to be a recipe for disaster. Your course critique are going to crash. You're going to invest so much time into it. You won't really know what the student will actually know. And so that was also, I was considering this, but there's also so many success stories that you hear about it that I said, I'm going to try it. And I'm not going to lie, it took time. There wasn't any explosion, no failure, nothing. It was a lot of monitoring, and I mentioned that in the small abstract. You had to be much more careful about what you were trying so that the student felt that they were learning in a safe environment. But there were so many times where the student were so engaged in their learning, and they were excited, and they were actually learning and remembering it. I saw it in the final exam that it really was worth it. On that level. So it was definitely, the road ahead wasn't very easy, but it was definitely worth it. So with the Teaching Excellence Academy workshop, what I did is that I started to see my course differently. That's where I mapped it out. With material science, one of the best examples we have is the failure of the O-ring that led, to the explosion. So that was always something, that I mentioned as part of there's professional engineering in it, but the material science was really cool. So that was one of the driving forces that I started to kind of picture my course like this big space shuttle vessel that was going to the moon, and that's where the knowledge was and how were we going to get there. So all the stars were representing, what I was going to try them to get through with the different experience they would see. So that's where we started looking at introducing different activities. So what I had to do, and that's one of the key things with a flipped classroom, is that if you remember looking at my course outline or the content, there's lots in there. There's no way with a flipped classroom I could assess and cover all this. But one of the things that we do, and we'll often talk about this, is that one of our jobs is to teach students how to learn. So as long as I could select the concept that I really wanted to be taught, and I could make sure that the way I brought them there would allow them to know how they're supposed to learn some of the material on their own, eventually depending on the problem they face, then I felt that I could do it. I could, remove some of the component, and it wouldn't change the course too much, and I would get them the knowledge that they really needed. So basically, what ended up happening is that, again, with the course objective, and that's where, with a flipped classroom, there's no real recipe that I can give in a way, but one of the key things, that's where alignment, your course alignment. So what are your methods of assessment? What are your course objective? What are your learning outcome is really key, because suddenly you're in an environment where the students are not just listening to you anymore. They have to work It's open-ended most of the time. I'm around, but it's an environment where students also feel a bit unsafe about how they're going to learn and what they're learning, just because there's some structure, but it's not a lecture structure. You're not telling them, okay, we've covered 50 slides. This is what you're supposed to know. It's all in there. Suddenly, we work in the classroom, and it's open-ended, and sometimes there's solution, and sometimes they're not. And so one of the key things was, for me, if I know where I'm trying to get them, and I can have my path really straight forward, and it's all lined up, then I can get them there, and we can be successful. And that was really key for me. Once I had it all settled in my head what I wanted them to know. So what were the course objective? And there were the basic ones. So looking at the Bloom's taxonomy, just the knowledge base, and then some of the key component was the application. There's a description, the explanation, the identification, but also where I was really trying to get them, that was my main objective that I really never got when I was just doing it as a regular lecture, is being able to have them integrate some of the basic material science and chemistry and develop some critical thinking skills. That's kind of the thing. You, as an engineer, they're set in front of a problem and they have to solve it. And often, because I was spending so much time lecturing them about what they needed to know, they never got to actually look at a problem and take it apart and see really what was a key component. So with a flipped classroom, we're able to do that. Actually, we did that in the classroom all the time because they could read the material at home, and then we could apply it directly. So once I knew, I had my objective, and then I was trying to get there. And so I cut down some of the concepts, so you can see the schedule of the course. I had 12 weeks. I picked 12 concepts that we were going to go through, and every week the way it worked is that it was 2 hours of lecture and then 1 hour of lecture and 1 tutorial. And so basically those became what we called working sessions. And so they weren't lecture anymore, it was all blended. So it was working session where they would have different things. So basically they knew that every week was associated with a topic. That's what we were going to cover. They had some reading to do, and they had an online quiz. Because one of the things, again, because suddenly they're on their own, they have to learn the material, I also need to make sure that by the time they come in the classroom, they've read and they're prepared, because if not, they're wasting their time. And it was actually interesting in the feedback, in the course critique, some of the students said, well, if I didn't have time to read the material, the class was useless. Well, I'm like, yeah, well, I guess you got it. At least you realize, unless you come prepared, you can't do anything. And so the online quiz, it wasn't worth a lot, and you'll see what it was, but it was really there for them to allow them to go through the material. And the quiz was simple, and I said, there was no time limit. I say you can answer it as you review the slide at the same time. And so it was really open for them to do it on their own time. They had to do it for sure before they were coming into class. But it also allowed me, what I found is that a few things that we were looking at, especially in material science, there's some vocabulary that they need to know. And there's a spelling. And with the quiz online, they had to type things. And so they would get really upset because they would miss a point because they misspelled. I can't remember what the word was one day. But anyways, they misspelled, failure or something. And they're like, well, it should be fine. I'm like, well, no, this says, you can't call something differently. And you need to know how it's spelled because it's a technical word. And so it also allowed them to kind of start applying some of those words that are key descriptive for material science, and also understand that you can't just use jargon without knowing how it's spelled, what it means. And that was an easy way to do it to an online quiz because I didn't have much to do. It was all automatic because if it's the wrong spelling, well, it's not counted. So it was really good. It was a good teachable moment because it really got them to understand certain things. And I would have been able to do that during the midterm exam and so on, highlighting and circling in red when they were spelling the word wrong, but they never look at those. They never remember any of this. Because, you give them back their assessment and they usually barely look at it. When you have the feedback directly right there with the online quiz, I think that was actually one of the really interesting outcome of this, was having this feedback telling you, well, you don't really know what you're talking about. And so they would go back and look into it and say, oh yeah. So they complained at the beginning, but eventually I think they understood why we were doing this. So that's kind of how it was structured, that only about 12 concepts were selected or topics were selected, and basically every week we went into this after they had prepared and read the textbook. So what we did, and I wanted to see how big it would show up, but it's not great, but basically what we did in every work session that I had with them is that I would come with a sheet of paper that had a set of problems in them. It was never posted early, so I wanted them to be in class with me and discussing them. If they weren't in class, then they would get it the next day. You know, they have co-op interviews, so sometimes they couldn't come or they were sick. So I wasn't not going to provide it to them, but I wanted to make sure they would show up and they would use it. So I unfortunately killed a lot of trees. There was a lot of paper, but it really forced them to be there and also to start, you know, writing down things. I was amazed at the number of students that showed up to class with no pencils or no paper. And it's a, you know, and it's a working session, so one would expect that they would know that they have to start taking notes and work. And so it took a little bit of time for them to get used to the fact that suddenly they just can't sit there and wait for me to tell them the answer, because I wouldn't do that. So it was kind of interesting. So the way I had done it, and you know, I was trying to, for me again, to make sure they were learning the concept, I needed to be really organized, and that's usually not how I am. So it was kind of funny. But you know, I had to say, you know, what do I want them to take away from that session? What are my learning objectives? And so then I had some questions that related to this. And at the beginning, I put the learning objective on this paper I was giving them, and then they were all the exercise we were doing together. And what I found out is that they didn't even read those. They didn't even understand them. So we actually spent some time actually at one point, and that's where again, not only, you know, what I found with the flipped classroom is that you get a different kind of engagement with the student, but they start also understand, you know, what is the point of you teaching them certain things? Where are you trying to get them? And with the flipped classroom, because it's so different, I was very open that it was an experiment, and so we were talking a lot about how the class was run and why I was doing things certain ways so that they really understood, and that really helped. So when I discovered they didn't quite understand that, then I started removing them, and so, you know, we went with very simple one sheet that had very few questions at the beginning so that they got used to how things worked, and there were lots of questions, to having much more complex problem with graph again, and that's why I was giving them a printout so that they would have the graph, they could draw on it, they could conclude on that piece of paper. And so we would do that all the time during the working session. One of the biggest or the hardest thing that I found was the timing. You know, I would come up with those worksheets for my 2-hour thing, and in 2 hours I would cover half of it. And I'm like, oh my gosh, this is not good. Like, how do you? So it took me a while, you know, to get to the organization on having enough material and not too much, because then it becomes, you know, you bring a sheet and they have to remember to bring it back, and you never know where you have to be at. So I got a lot better by the end at really knowing, you know, how long is this going to take? Because at the beginning, I had 7 exercises, and there's no way. Because there's so much discussion, and that was kind of the fun part, is that we were going through the concept, and, you know, there were some students that weren't understanding some of the problems. So I would basically, you know, it was a class like this, and I would be with them, and we would be doing it together. And then another group would come forward to kind of see it. There were some peer interaction, of course, and so they were teaching each other, and then we would do kind of a class wrap-up of how this would happen. So it took a lot longer than I expected at the beginning. And eventually, by the end, I understood how long some of those would take, and the discussion that would ensue. Because it's like a lecture, you know, you have questions, and sometimes you take them and you don't, and some question could last 15, 20 minutes. And that's really what I wanted for that class, is that the interesting question, I wanted to be able to have time to address them and work on them. And so that's what this allowed us to do, because at some point, some of the exercises were repeats. So I said, you know, we'll just post the solution online, and we will just be fine. So one of the other things, too, we were doing in the classroom was, you know, they had to work on this problem in pairs, and then we would talk about them. But I also wanted to kind of get a direct feedback about what did they learn, and did they understand some of the concept. So I had those class participation activities that we had at every end of the session. So you can imagine I had 12 weeks, 2 sessions per week. So that was many, many different, that one that we collected. What was really good about it is that for me was direct feedback about have they understood or not the concept. So I would go home basically and then go look through them and see, what have they understood, what seems like something that they don't grasp, or what are the common error. And then the next time I saw them 2 days later, we went back directly right then and down. So that was also very helpful because they remembered, they remembered what we had discussed. So it was really easy to go back to it. It wasn't like an assignment where, you give it to them, you get it, the TA mark it. Even if there are some recurring mistakes, usually you can even do a pause. That's what we used to do. We used to talk about it in class, but they usually had forgotten what it was all about because we had moved on. So with this, it was really neat to be able to get direct feedback, and that I really enjoyed being able to do that. The only thing is that I collected a lot of information, and that's where I'll give you some of the change that I'm going to make to actually help with this. But that was a really important piece of their learning too, is being able for them to kind of assess. So sometimes it was done in pairs, sometimes it was done individually, some of the writing. And one of the things that I wanted them to experience was being able to critically analyze a graph, for example. And so they did that individually, and I read it all over, and then I would show them like the best one and the one where, it wasn't too great and why I didn't think it wasn't that good. So we did a little bit of peer critique at that level. So that's kind of the working session. Most of them were like that. Well, no, most of them, they were, I would say 80% of them were like that. And then we also had case studies and idea clinic. And the case study were basically a time where the classes was divided in 24 groups. And they had a problem to work on. And they were all different. So one time they had to develop a set of slides to teach kids about a neat fact about material science. Another time they had to come up with an argument about why it would be bad to remove funding to test materials for IAD. They had to test material for icebreaker vessel or Formula One or a space shuttle. So I also gave them a choice about the application. And so they kind of really liked that too, because we were doing case study where they had to apply a specific concept, but they could pick, is it going to be an icebreaker, or is it going to a train or a space shuttle? So some of them really liked the space one. So we did 4 of those. The most memorable one for me was the last one we did actually on stents. So this is a system design class. So I would say usually maybe 20% of the students are interested in the biomedical field. The energy that was in the class, I had given them like a short information about what a cardiovascular stent is. So it's basically a little spring that you put in your blood vessel to kind of open your coronary arteries into your heart when there's a blockage. So that was kind of what they knew. And then I asked them they were giving a set of material properties of the current stent, and they had to pick an improvement one. And they had to, that's where I wanted them to apply some concept of design and other things. So they had to think about, how easy is it going to put in, and what are the different properties of the stent and things. And the class was buzzing. They had so many questions, and they were like, well, how do we pick, and how do we make sure that it's biocompatible? And I was like, I didn't even think they would go there, but they really got into it, because suddenly this is, a brand new problem. They have to apply, they have all that data, and they have to select, and then they had to write a memo to their boss. So I kind of made it in a way that it was, they had to deliver a written document, but it was just really interesting to see them trying to find the information. And some of those were run with a computer. So that's also what I found, is that whenever we were running some case study, if it was done with the computer, they would not try to really use their brain. They would go Google something. And I kept telling them, you guys are smart, like things. So some of them I say, you bring your textbooks, you bring no notes. If you're bringing your computer because it's on your computer, that's okay. But if I see you on the internet, you get a 0 on that. And that was actually really good, because it also forced the interaction in some of that group work with peer learning, because usually, they're on their computer, they do this thing, and they don't really talk to the 4 people of 5 people that are around the table. So that was kind of interesting. Some people don't like not having access to their computer, so I definitely got some slack on that with my course critique, but overall it was something that I think they got to see that, yes, they can use a brain, and I know they could, so it wasn't too hard to convince them. The other thing that we started to do too was the 2 activity for the IDEA Clinic. So again, hands-on experience was something that I really wanted the student to have a chance to do, so we basically made bioplastic and we tested it. And one of the interesting that I found with that is that, I teach them about material science and variability and material properties, and it's 300 megapascal for the stiffness, but it varies depending on what you do and so on. And so they finally got to actually make something and test it, and it was like, oh, it didn't work. Oh, like we don't get the same value. I'm like, yeah, this is, whatever you're seeing, and you have to think about those. So it was really good for them to actually experience what it is to actually synthesize your own material with some recipe. We had done it, and some people are here from the IDEA Clinic. We had done it like 5 or 6 times. It worked really well. And then, the time we tried to do the same one, I know with Eileen, theirs got contamination. Mine, so we were trying to prevent contamination. We were protecting it, so it was changing the way they were drying. So everybody had slightly different sample. And it was interesting too then, because then I told them once they had done it, so as they had to do it the first time, and then they came back the next week and tested it, and they had to work as a big group of people that kind of had the same material with slightly different variations. So they had to start thinking about, how does it affect properties? And again, it was just how interested they were in it, and they had to test it, and I wasn't giving them anything. So, some of them brought orange juice and vinegar, and they looked at dissolution. Some were testing the transparency with their cell phone, or it was my laser pointer. So it was really interesting to see what they were able to come up with and writing small report. And this was supposed to be 2 hours. I would say most students stay extra to finish and do more experiments. So again, it was one of those things where they were in an environment where they were testing, they were applying all their knowledge, and getting something actually quite important related to, the variation that you can find with material, and how you can, depending on what you put in it, you will change the properties of the material. The other one that we did related to shape memory alloy, and it was again looking at, this one was more looking at integrating a little bit of their electricity course and the material science course. So it was something that we did to try this out. So overall, those worked really well to kind of add a slightly different flavor to the course, because I wanted to make sure it wasn't all working session. So that, they were different learning environment, learning opportunities for them. So one of the things that came up several times was just about around the test is that, we're working all the time, but we really don't know what we know. And I also wanted to make sure that I taught them what I thought I did with all the different exercises that we did. So something that I came up with was to do what I call like a recap thing, where I actually look at all my learning objectives for each of those weeks and mapped it back to all the exercise and learning opportunities we had. What was really interesting is that I found out that actually I had one learning objective where I had no learning. I didn't teach them that in the exercise I thought I did. So it actually forced me to remove it, because I'm like, I can't test them on this, because really we didn't really do anything about this. So it was actually also really interesting on my perspective, is that suddenly, I thought we were doing all this, and I didn't have an exercise that talked about this. Implicitly, maybe I could have found it out, but I couldn't really say. So it was again, and that's where it was a flipped classroom, because it's such a different environment, and you have to be careful and make sure you give them that safety net and that scaffolding, and that's what I used to call it, so that I can get them to where I want. That also really helped me to make sure I was giving them the right learning environment, so that I wasn't failing them at that level. So that's something that worked out really well. It took quite a bit of time, but really good, and it was a good way to also looking at it a different way I was teaching them or getting them to learn those concepts. So the way we assess the knowledge for the course, as I mentioned, there was those online quiz, so that was kind of really small and silly in a way, but really good for forcing them to look at the material, but also correcting those little things that would come up. Because it was the first time I was doing it, I also wanted to make sure that I wasn't just going to give them a midterm to assess their knowledge and then move to the final, because I thought, you know, if something happened, they've got no way to catch themselves again. So what we did is that we did 2 small tests, and that was closed book. They were small exercise, very similar to the working session exercise that we do. There was one little exercise on critical thinking so that they could get some feedback about how to get better. Because really what I wanted is that I wanted my final exam to be all about application and critical thinking. So I wanted that, but I didn't want to fail them. And so I put those in the process so that they could get some feedback and learn a little bit about it. So the way it worked is that grade-wise, that's what it was. So it was all little bits of component that allowed them to earn some grades, and there was nothing that was too big that would get them to fail. And so I think overall, although it was a very different experience for them, it was a fairly safe environment for them to try different things too. And I think that was kind of also why the class was successful, is that they kind of knew where they were going. I knew where that was going, and there was no way they could fail just because they didn't quite get some, or they didn't like the learning environment that we had. Something that really was key too is that with every of those, there were some really great teachable moments. You know, I talked about the online quiz. It was the same for the class participation. The final exam, actually, I gave them a piece of plastic to analyze. So I synthesized bioplastic for 2 days, and then all gave them a piece of plastic. And I asked them to compare it to Saran wrap and tell me what they could do. So I also gave them Saran wrap because I was unclear if they would remember what Saran wrap looks like and so on. But it was, you know, it was finally testing them. What I wanted to do is apply the knowledge. But I never felt safe about doing that when I did my regular lecture, because I didn't really know if they could do it. Based on how I taught the class, I'm like, they got to be able to do it. If they can't do it, then they should fail, because they haven't really participated in the class and engaged in their learning. So that was really something, and that's where, again, we're applying the knowledge. You know, the first 2 we didn't do too much. The mini research project, that's where they picked something that was of interest and look a little deeper in the properties. But that's really where the final exam for me allowed me to test that outcome. You know, can you actually do this? And so that's what it was all about. And actually, a few students at the end said, oh, I almost had fun at that final exam. So again, it was kind of, when I told them, I would give them samples, they were like, wow. So it was kind of neat to see, you know, I don't think I never dreamed I could do something like that. And I thought it was kind of neat. So I'm going to have to think about something else for next year. But it was a really great way for me to really assess if they could apply their knowledge. And also I was telling, somebody at OEF, you know when you grade your final exam and you're like, oh my gosh, I can't believe they didn't get this. I didn't have any of those moments this time around. And my exams are usually about the same. You know, it was the same. And so I clearly felt that I actually got them where I thought they should be. So that was really exciting. So, you know, overall results, I didn't fail any student, actually. Usually I failed 1 or 2. So that was nice. And most people actually showed up at the class. There was definitely a deeper level of learning achieved to that. The class average also was higher, and I think that was a reflection. The first term test, I have to say, because I was unclear about where they were, it was a bit too easy, and I told them actually so that they knew the second one would be more difficult. But you know, it was good because I kind of saw the average. I thought it was easy in a way, and they did have a high average, so I guess I knew where I was going at that level. Course critique-wise, you know, I thought that's going to be really bad. It actually got better. So it worked out really well. I won't lie to you, it took a lot of time, but it was fun time. I had fun every time I went to class, so it was kind of good. There were definitely a certain amount, or there were certain kids that really didn't like it. And it was really interesting because one of them would sit in the front class row, and it was kind of not always fun to have him there. But, you know, by the time we finished, I think I actually convinced him. So it was really interesting to see how he was a bit against it and the whole model. But there were even like about with 10% of the kids not liking it, obviously the course critique weren't affected. And really it was just, they just want to be taught. So I was looking at them last night as I was preparing this. I had some people that say, you're the god of flipped classroom model and so on. And I had some other were like, you should really just teach and lecture us. And so it was like, but there weren't too many of those. But it was kind of funny to see, how that did. But even the one that didn't like it, they didn't bring the classroom down. And I think one of the things that I really was very open about is the experimentation with flipped classroom. And so there was a lot of discussion, I would check in on them almost every week about, how do you feel about this, and are you understanding the concept? And I think that's also where it worked out really well, because it is a different kind of learning for them, especially in engineering. So that was something that I thought also helped make it successful. What did I learn? Something that I learned again, and I just mentioned it, is a clear communication with a student, about what my expectations are, so that, and how much prep work is key too. So, the week I knew they had midterms, I did a lecture, I knew they had midterm and 5 courses. So I said, I can't, or we did an activity or something that didn't require a lot of prep. So also it was about being open about some of the expectation about how much I can expect from them. So I think that was quite important. Organizing the online material too, this is what I rely on for them to learn. So it needed to be very organized, which again, as I said, that's usually a little bit of my weakness. And so I had to stay on top. So that was something that was quite important. Also, as you saw, I had class participation every week, actually every working session. So you're looking at 2 a week. Our students have co-op interviews. So, I wasn't saying you're going to get a 0 if you're not there. What I said, you can't make it. I want to make sure you're able to, the material. So I posted about 5 or 6 assignments that they had to do, and they could actually gain their points back if they did those. So, I knew then that they had actually reviewed the material that they missed, and that way they weren't losing any points, and I wasn't using my TA to mark assignment that really they would never looked at. So that's kind of a way that I was also helping them, if they were sick or if they have co-op interview, and they didn't have to come every time saying, oh, I can't make it, can you do something for me? So I said, no. This is a rule. If you miss it, you can hand in your assignment and then you get the points. Also, something that I didn't do and I got some feedback about is my slide, I only posted my slide in the textbook. I didn't have time to record anything. I was thinking about finding some YouTube video, but never got around. And that's kind of where some comments were related to, I don't quite learn very well by only text and things. I need a little bit more visual. So that's something I'm going to work for next year, is actually finding those. I'm not planning to tape my own, because there's lots of material online. So I don't really think I need to do that. I just want to have some supportive material for the different style of learning at that level. And as I say, even the student that didn't really like the flipped classroom and ended up getting engaged in some of those activities, and that's why I thought it was important to have the different kind of learning opportunities. Some of them were much more, worksheet and working together as pairs, but also as small labs, so that way they get to at least enjoy something in the flipped classroom. Another thing is that, that kind of classroom, at least those that have wheels, are not made for flipped classroom. So it was, but that's not going to stop me from doing it again. We'll just work around it, because it's so much worth it to actually get them to work in group and so on. So I used other classroom at times, or we broke down in groups. So sometime, they didn't show up in one week and they came up another week. So I kind of worked a little bit, because that's what I discovered is working in smaller groups work a little better for me too. To be able to interact with them, because if you're interacting with them in a classroom like that, the kids that are in the middle, you never get to them because there's no space. So that's something also that I learned. And the other thing is that my TAs, they didn't know what to do with me. I worked with a student a lot to make sure that they knew where we were going, and I was trying with the TA, but I just didn't have that much time to actually do it. So it's they're not used to having in the classroom, because that's what happened. They were there with me to help me with the interaction. and some of them just didn't know what to do. So one of the things that I'm going to do for next time is I collected also even the grading and the critical thinking feedback and so on. You know, they're not quite used to that. Usually it's 0, 1, 2, or 3 and very little comments. And so I've actually kept example about what I expect as like a good and a poor so that I can actually train my TAs. So that's going to be the next thing that I'm going to do next time I offer the class at that level. So change for next year, I guess I already mentioned some of those related to a classroom. Something I'm going to do is actually, I do have those class participation that I'm going to keep, but I'm going to use Clicker to have feedback directly as we do those exercises, because it will allow me to have feedback from the entire class. Because usually I would get feedback from the people I interacted with, and I didn't feel that it was fair that I only consider those, so I'm going to I will implement that next year. And so for the class participation too, what I'm going to ask them is actually take a picture and upload it on Learn so that it's easier for me to have access to it, and they also have access to it later on. Because giving it to them is always so hard with 90 of them, so that was one of the things. I also, something that I think it's Gord actually had sent me something that the math faculty is doing with Flipped Classroom is adding extra tutorial time. And so that's actually what I was able to do, is that I'm going to have an extra hour and I'm going to divide the class in two so that I actually have, every week, I've got smaller groups to work with for a little bit of the time. So I thought that would help me. And then as I mentioned again, using some online video to actually help the different style of learning at that level. So that's really most of my stories about Flipped Classroom. And again, as I say, it takes time, but it was so worth it. And I really learned, you know, for some courses it may not work, but for the one I taught, and I taught one in the summer, and actually I did lecture-based, and that was the hardest thing, because in the back of my head, every time I was showing up in class, I'm like, it should be a Flipped Classroom, but I just didn't have the time. It just didn't, it was too late, so it just trying to implement it is definitely something that takes time, but if you're willing to make the investment, it pays off. So if you have any questions, I'd be happy to answer them. Yeah, Jason.
So it was that was really neat. Thank you. Obviously, it was quite a lot of effort on your side to put this all together. In terms of the students, how do you think the total effort required for the class was the same as it was for a regular class, or did it change?
Yeah, no, I think it was the same. Some students said it was a lot of reading, but you know, they didn't have to do all the assignment that I had previously given them. So overall, I would say overall, from all the people that complained about the work, it was a reading, and it was about 10%. It wasn't something that came up. I know something, there's a university in the States where they're trying to do all their classroom as Flipped Classroom, and then I would be worried. Because that would be a lot, but as a one-off, and also being sensitive, you know, what I did is that I would post the material a week ahead and says, this is what you have to do. And so that gives them time to figure out when are they going to read it, when are they going to do it. So that requires a little bit of organization, but the amount of work, like if I look at my course critique, it wasn't an issue at all. And again, it's based on what I was trying to make sure that there wasn't too much, because I was sensitive to the other course too. Yeah.
Did you notice an increase or a decrease in the class average for this course?
It went up.
Went up?
Yeah.
Percentage-wise?
It went up by 4%.
Is it because of the change in the distribution of the grades? Like actually you changed the
Yeah, I changed that a little bit, but you know, in some of them I was actually a lot more. My expectation were higher, for example, in the case studies, because we did so much more work on developing critical thinking skills and applying concept that, you know, I was actually very strict about not giving easier grade as I would have in my previous one. I think one of it was the test was a little bit easier, but for the final, the grade definitely went up compared to previous year, but it was the same level of difficulty actually.
So maybe a good comparison would be the final exam grade. Was it the average of the final exam?
It was higher. It was, yeah.
About
And
what percent?
it was 25%.
25%.
Yeah, so which was,
That's like
yeah.
a
Yeah. And it's really, my final exam, I usually give them one so that they have an example. And so it's usually very similar. The only thing I added was this applied, you have a sample. And again, I was very critical when I was grading that, because it's not like they didn't have the chance to practice. And that's always what I found, whenever I had those critical thinking questions or applying your knowledge, it was hard to be, to have high expectation, because I never felt that they had enough chance to try it and get feedback. And here, that's all we did. And you could really, and that was the neat thing, is that you could really, with some of the students, it was really interesting to see the progression. The one that really could look at a graph and would just state, well, it's going up. I'm like, well, that's great. I can see that. Can you tell me a little bit more? I'm asking you to explain. And so going from, I can just look at it to actually apply that knowledge and make a decision based on that. And so that was kind of the neat part too. And I did that with some of them, with some of the students, where I actually followed them a little bit to see their progression, where at the beginning they weren't very good, and then they got a lot stronger. And so that was also the nice thing to see, especially with the final. There was definitely between the test 2 was a little closer to critical thinking, and seeing how they were able to actually improve was quite nice. Carolyn, first?
You say the class average was about 4% higher than previous years. How did that same cohort do in other classes where they didn't have a flipped thing? Were they all just happened to be a bit brighter than?
No, they were the same class. Yeah. So no, they were no brighter, and it was the same size actually as the one before. Yeah. No, but that's a good question. Yeah, definitely. But that one wasn't brighter. Yeah, over there.
Yeah, I also teach a material science class, and I realize how much work this is. So I'm a little intimidated. I'm thinking, for someone who wants to do a partial flip, maybe a couple steps, what would be your baby step approach? What 1 or 2 things would you recommend to do? Because I don't know that I can do this.
Well, another saying, yeah.
What do I do? Case study here?
The case studies were really, and that's how I started. I wanted to make the class a little bit more engaged, and so that's what I started with a case study, and that's what happened. When I taught in 2015, coming back from sabbatical, really missing teaching, and enjoying the teaching, but finding that I was bored, I talked to the student about, I was thinking about the flipped classroom, and they were like, oh yeah, do it. That should be so cool. And I was like, okay. And then my husband was like, this is crazy. This is going to be so much work. So I kind of, and I tested the water with those case study. And the first time I did them, I only had 2 that I developed myself, and then I added another one, and then another one, because that was the thing with the case study. I would post online. They would have to select the topic and start doing some prep for it, because they would come in the classroom. They had 2 hours and a half usually, and there was a deliverable at the end. I wanted to have a memo to the director of mechanical properties or whatever. Or I wanted a set of slides. There was one where I gave them a chance to resubmit if they wanted to, implement something else. But then we would compare. So they couldn't do nothing in class and then do the thing at home. We would compare. So, if the thing was poor from what the time they spent in the classroom and was magnificent afterward, they would lose half of their point, because it's like the time is for the classroom. You're not supposed to be doing that at home. But yeah, the case study would work really well. And that's when also they start learning as groups, and where you can interact. And again, that's where having TAs that are ready to answer questions. I would tell my TAs, you need to prep for those. And they're like, well, I can't find any information. I'm like, well, you need to know where to look, because you're going to be the one that are going to be helping the students. So it was, again, one of the things that was harder. Wayne?
Yeah, so I might be behind some of the other people in this room in terms of this flipped classroom business, but I'm still thinking about what is it you're trying to achieve when you meet with the students and so on. So in the traditional form, the instructor tries to make a basic idea clear, then show how it applies, and then give them students some things to do, homework, for example, where they own the idea. Those are sort of the 3 standard steps.
Yeah.
Now, talk to me about what you're trying to do. Where are the students supposed to understand the idea?
So,
Where
yeah.
are they supposed to figure out how to apply?
It's some of the steps, when you have a problem, and I wish I could think a little bit more about some of the example that we've had that happen, where you're sitting with a student and they're working through the problem and they stumble. they stumble on the problem. And so if you know they stumble on the problem when they're at home, I'm not sure what they do. You know, Gord?
It might help if instead of thinking about the process of learning, think of different styles of teaching and think outside of engineering and university. And for the flipped classroom, I think the one that you want to think about is think of a master and apprentice. The apprentice works, the master watches and steps in
Yeah.
at the right time to give feedback, to push, to prod, and all of that.
Yeah.
So think of it not so much as in the sequence, just think of different ways that mankind has learned.
Yeah, and I think the master apprentice thing is really key because that's exactly what happened in the classroom. You know, they work on it and then, you know, I'll see something and then I go to them. And that's what happened is that usually you can never do that in a regular classroom, even during the tutorial, because it's so short. Usually it's all board and exercise. And so this allows you to do it on different level. And really that's where I found, you know, some of the step that's usually the time where they would get stuck. And you know, it's also as you're with them, then you start, you know, discussing the concept that they're looking at and it expands. You know, you end up going a little bit on a tangent and they're going to kind of share some of their ideas. And so that's also where the deeper learning comes, is that suddenly you've got this little window of time where you're talking to them as they're developing their ideas and you're there to help them guide. And that's really key to me.
I see a lot of really good things in this. You know that that's what I'm thinking.
Oh, yeah.
Trying to get my head
Yeah.
around how to do this backwards.
Yeah.
Because I had a question. Because when I flip my classroom, one of the problems that students encounter is we have more than 100 students in the class. I was not enough.
Yeah, so that's where you TAs, and that's, you know, it's the same that I found is that, so the TAs, the rule was they didn't have a lot of marking because, you know, we didn't have the assignment and stuff, but they had to be in my classroom all the time. And that's where I found they didn't know what to do. I was really, because they would have been given some of the solution and I would tell them, you're not giving the solution. You have to be there to answer question. And that's why I found it the most difficult, which is partly why also I'm dividing the classroom in two, so that I'm going to have, you know, 45 of them where I'll be right there, but also that's what I'm finding is definitely there's a need for us to have, you know, we have TA expectation and we look at gradings, but also thinking about how do we train our TAs for that kind of learning environment, which is very different for them too. And I hadn't thought of about that at all. That was not even in my radar, yeah.
Do you have an ideal number of students to TA or yourself ratio?
Well, there were 4 of us for 90. And that's where, again, the classroom setup is very important. Because the way we had our classroom, it was, yeah, honestly, I know there were some students, and when I realized that, that's why I started making an effort to be much more aware, because it's also a peer learning time too. That's what happened, is that's what those working sessions are about, is that you give them those problems and they're going to teach each other and then convince each other about what, you know, what's the right question and what not. And that's when they start, then you come. So that's why you don't need to have like 20 of me, because they can go along and they're not going to get all stuck at the same time too, especially because there's a variety of activities that they do. So that's also definitely, but yeah, 3 or 4 is definitely what I needed. Yeah.
I'm very aware of time, so my suggestion is we do the formal wrap-up and thank Maude. I personally want to thank Maude because she made 2 really good plugs. One, Teaching Excellence Academy. Somebody asked about the workload, and I will be honest and say, Maude's right, you're still going to have a big workload, but if you want to reduce that workload, probably by at least 50%, do the Teaching Excellence Academy before you try this in a big way. It'll have a huge impact. And the other thing, which is my lead-in, is that Maude mentioned threshold concepts. We had a big event last October on threshold concepts. We plan on having a similar type of event this year. We've got Julie Timmerman back from CTE to help with the event. Tuesday, October 25th at 2:30 to 4:30, E5 2004. I've got a couple of brochures. We'll be posting this too everywhere we can. This year what we're going to do is move over to the assessment side. That is, if there are some crucial ideas in your courses, Are you truly examining your students on these crucial ideas? How do you get the information out in ways that you need it? And
Yeah.
actually, Maud actually
Yeah.
opened up the door a little bit for us.
Yeah.
And so again, I'd like to thank Maud
Thank
for
you.
an excellent presentation. Very, very